Assalamualaikum everyone, it's me Samia Slim from MS Chemistry first semester. Today my presentation topic is UV visible spectroscopy. First of all, we will discuss about UV visible spectroscopy's definition, then working principle, then design, then fabrication, and then characterization. Now, spectroscopy is the branch of chemistry concerned with the investigative measurements of the spectrum. UV visible spectroscopy is an analytical technique that measures the amount of discrete wavelengths of UV or visible light that are absorbed by or transmitted through a sample in comparison to a reference or blank sample. The property is influenced by the sample composition, potentially providing information on what is in the sample and at what concentration. It ranges from the vacuum level ultraviolet region from 180 nanometer to the visible region 780 nanometer. UV visible spectrum extends from 180 nanometer to 400 nanometer, whereas the visible region ranges from 400 nanometer to 780 nanometer. Now we will move to next slide, that is working principle. The principle of UV visible spectroscopy is based on the absorption of UV violet light or visible light by chemical compounds, which result in the production of distant spectra. When matter absorbs ultraviolet radiation, the electrons present in it undergo excitation. This causes them to jump from a ground state, an energy state with a relatively small amount of energy associated with it, to an excited state. It is important to note that the difference in the energies of the ground state and the excited state of the electron is always equal to the amount of ultraviolet radiation or visible radiation absorbed by it. And now on next slide, there is a picture of an spectrophotometer and its and now we will move on next slide, that is fabrication. The first one is the light source. As a light-based technique, a steady source able to emit light across a wide range of wavelengths is essential. A single xenon lamp is commonly used as a high-intensity light source for both UV and visible ranges. For wavelength selection, in the next step, certain wavelengths of light for this include, the first one is the monochromators, and the second one is the absorption filters, and the third one is the interference filters, and the fourth one is the Kudow filters, and the sample analysis. For all analysis, measuring a reference sample, often referred to as the blank sample, such as cuvette filled with a similar solvent used to prepare the sample, is imperative. If an aqueous Buford solution containing the sample is used for the measurements, then the aqueous Buford solution without the substance of interest is used as the reference. When examining bacterial cultures, the sterile culture media would be used as the reference. The reference sample signal then later used automatically by the instrument to help obtain the true absorbance values of the analytes. Detection. After the light has passed through the sample, the detector is used to convert the light into a readable electronic signal. Generally, detectors are based on photoelectric coatings or semiconductors. The first one is the light source comes, and then the wavelength selector, and then its sample, and then it goes to a detector, and then electronic current like computer for signal processing and output. And then its characterization, optical properties of semiconductor, quantum nanoparticles, then its predict nanoparticle geometry, then it's determine the nanoparticle aggregation states, and then its nanoparticle surface composition, study of chemical reactions.